going to take a quick look at using our calculator to convert from an angle measure to a ratio or from a ratio to an angle measure. I'm going to ignore this top line here. The angles don't have to be written in decimals. We can enter them in however we need to. But we do want to make sure that our calculator is in degree mode. And take a look at our calculator over here. Here's the mode function right here. Mode. If you go down to line number 3, make sure degrees is highlighted. That at least applies for now. As we progress through the book, we will be changing back and forth between degrees and radians as two different angle measures. But here you can see sine, cosine, and tangent are used to convert angles to ratios. So I'll refer to these oftentimes as the original functions, sine, cosine, and tangent. So if we want to find the tangent of 30 degrees, that's what we do. We type that right into our calculator as the tangent of 30 degrees, and that gets us a decimal value of 0.57735. If we want to find the cosine of 45 degrees, that's what we do. We type in the cosine of 45, and that converts that angle of 45 degrees over to a ratio of 0.7071. As we've gone through, we learned back in chapter 1 a little bit, our reciprocal functions of cosecant, secant, and cotangent are not on our calculator. It's just sine, cosine, and tangent. So if we're going to find the cosecant of 30 degrees, we use our reciprocal identities and say that's 1 over the sine of 30 degrees. So 1 divided by the sine of 30 would get us the cosecant, and you could see that would be a value of 2. Or if we wanted the secant of 60, we type that as 1 divided by the cosine of 60, and that would get us 1 divided by the cosine of 60 should also be 2. Okay, so those are conversions to move from angles to ratios. The other conversion, if you look on your calculator, you see these inverse functions. That's how they're read: inverse cosine, inverse sine, inverse tangent. They're used to convert ratios to angles. So going back to my calculator, if you look right here, the second function of sine or the second function of cosine, second function of tangent are those inverse functions I just talked about. So those are used to convert ratios over to angles. That's an important point to recognize. Let's see here, off to the side, let me see if I can't find a spot here. I'm going to write a basic trig function that says the sine of an angle equals a ratio. I'm also going to put the inverse sine of a ratio equals an angle. So as we progress forward throughout the textbook and through your mathematical career, you'll see trig functions written in one of these two forms. Obviously, sine, cosine, tangent could be inserted here as well as cosecant, secant, and cotangent. But the bottom line is we have to be able to look at an equation or look at an expression and know whether we have an angle or a ratio. Right now, our angles are pretty obvious because they're always written in degrees and or minutes and seconds. Okay, so those will be pretty obvious. As we progress, we'll see angles written in another form, which is called radians. We'll talk about that in chapter 3, but they look nothing like the degree measures, so people often confuse those with ratio measures. That's why these two statements here are pretty important. I'm just writing one quick example here. If I had the sine of theta equals 0.5, it's written in this format here, but we're looking for the angle, so 0.5 is our ratio. To convert ratios to angles, we could actually rewrite this as an inverse function of inverse sine of 0.5 equals theta, so we would use our inverse function to convert that from a ratio to an angle. We're just going to zip through these handful of expressions down here and find the decimal value that goes with those. So you can see letter A says a sine of 49 degrees in 12 minutes. A couple different ways to type this in. I'm going to go this route, 49 plus 12 divided by 60. Notice my calculator created a parentheses, so whatever I type in is the actual angle itself, and there are 60 minutes in a degree, so 12/60th is our decimal value there, and that gets me a value of 0.756995. 0.7569950557. Now I've showed you that little, I don't know if it's a shortcut or not, but our angle function underneath the app, so I could also type in the sine of 49 and use my apps function here, or my angle, degrees, and 12 minutes, and you'll notice that should get us the same decimal value. So a couple of different ways to type that in. I think this is shorter or quicker, so I don't have to flip it back and forth with my second functions, so I got that decimal value. Oh, we talked about our conversion for secant. Secant is 1 divided by the cosine of 97.977 degrees. So 1 divided by 97.977 gets me a decimal value of, oops, that's not right, so let's try that again. 1 divided by the cosine, I missed the cosine, 97.977. And that gets us negative 7.205879213. Cosine is an actual function on our calculator, so the cosine of negative 246. And you see I get a negative 0.40673664431. Moving on to letter D, 1 divided by the cotangent. That's the same thing as our reciprocal function for tangent, so it's a tangent of 51.423 degrees, and that decimal value is 1.25398151. We're just zipping on through here. Tangent of 77, nothing special about that. Tangent is a function on our calculator until the tangent of 77 is 4.331475.874. Cosecant of negative 140, again, it's a reciprocal function, so 1 divided by the sine of negative 140. 1 divided by the sine of negative 140, and that gets us a negative 1.55572827. Okay, so real quickly we zip through those, handful. That's converting an angle to a ratio. I'm going to scroll down here and we're going to go the other direction, so we're going to convert ratios to angles. Now before we do that, I've already said that this would be the same thing as inverse sine of 0.9677 equals theta, but we need to have separate conversions for secant, cosecant, and cotangent. So previously, if I scroll up here, our conversions were the 1 over cosine, the 1 over sine, and the 1 over tangent. Those were our reciprocal functions. When we have inverses, or we're converting angle or ratios to angles, our conversions are a little bit different. So if I have inverse cosecant of a value or a ratio, we type that in as the inverse sine of 1 divided by whatever that value is. Or the inverse secant of a ratio equals the inverse cosine of 1 divided by x. And the inverse cotangent of a value is the inverse tangent of 1 divided by x. So comparing that with our previous, if I had the cosecant of an angle, that's with 1 divided by the sine of the angle. So notice our different conversions for our ratios to angles. They are typed in a little bit differently into our calculator. I'm going to go back to letter A. We've already written that out. So the inverse sine or second sine of 0.9677. Again, that's going to convert that to an angle. So we'll just make life simple here and say it's about 79 or 75 point, I'll go 75.4 degrees. Go to the nearest degree for right now. Okay, I just covered the reciprocal identities here. So the inverse or the secant of theta equals 1.054. 1.054 is a ratio. The secant of an angle equals a ratio. So we have our inverse function, inverse cosine of 1 divided by 1.054. Bringing my calculator back up, second cosine of 1 divided by 1.054, and that gets me about 18.4 degrees. We'll go ahead and do tangent, inverse tangent of 5.876. We're not working with reciprocals here, so we just type that in. And inverse tangent of 5.876 equals about 80 degrees or 80.3 degrees. Okay, let's just add a couple more on here with our reciprocal functions. Let's do the cosecant of theta equals 2.3456. Okay, reciprocal identity, so we're going to type that in as the inverse sine of, pen's not working very well, inverse sine of 1 divided by 2.3456. So in our calculator, inverse sine, or maybe not, we have to come back to this. Suddenly my calculator has stopped working. So be patient here while I open this thing back up. While I'm waiting for that to open, I'm going to go ahead and make up another equation, and we'll do that in just a second. So the cotangent of theta equals 4.66667. Okay, so let's see if our calculator is getting close, which it is. So we have it up on the screen here. So we'll go back and type in our inverse sine of 1 divided by 2.3456, and that converts that to an angle of about 25 degrees. We'll go 25.2 degrees. Okay, so I made up one more. We'll go through it and should wrap up our section here. Cotangent of a ratio, that's 4.6667. We use our inverse tangent to convert that over, and it's 1 divided by the 4.66667. So we'll type that in, inverse tangent of 1 divided by 4.66667. And we get an angle of about 12.1 degrees. Okay, so two different sets of conversions, just to summarize. One for our converting ratios to angles, so I'll put that here, ratios to angles. Those are our inverses. And then up here we have our original functions as well as our reciprocal functions. Let's just write those all together. Cosecant of an angle is 1 divided by the sine of the angle. Secant of an angle is 1 divided by the cosine of the angle, and the cotangent of an angle is 1 divided by the tangent of the angle. Those conversions are used to convert from angles to ratios. So keep that in mind as we progress forward. You have to be able to recognize what's a ratio and what's an angle. Again, right now it should be pretty obvious because angles are always written with degrees and or minutes, whereas our ratios are those decimal looking values like we have down here. We've covered our ranges back in chapter 1, so hopefully we're pretty clear on those. Anyway, that covers section 2-3. We'll be moving on to solving triangles in our next section.